In this problem, we will study the convergence of the power series with terms 1 over n times 9x plus 7 to the power n. We will precisely determine the radius and the interval of convergence of this series. We define the sequence Bn as 1 over n times 9x plus 7 to the power n. In order to determine the interval of convergence of the series, we will use the ratio test. The series converges if the limit of the absolute value of the ratio of the n plus 1 term to the nth term is less than 1. Now, we have to compute the limit of ratios. It comes that, the limit as n goes to infinity of Bn plus 1 over Bn is equal to the limit as n goes to infinity of 9x plus 7 to the power n plus 1 times the fraction 1 over n plus 1 over n times 9x plus 7 to the power n. The limit of the ratio can be reorganized as the limit as n goes to infinity of the absolute value of the fraction 9x plus 7 to the power n plus 1 over 9x plus 7 to the power n times the fraction 1 over n plus 1 over n. This is the same as the limit as n goes to infinity of the absolute value of the fraction 9x plus 7 over 1 times the fraction 1 over n plus 1 over n. We can pull the fraction 9x plus 7 over 1 out of the limit expression because it does not depend on n. Thus, we only need to compute the limit as n goes to infinity of the fraction 1 over n plus 1 over n. The limit of the ratio is equal to the absolute value of 9x plus 7, which must be less than 1 for the series to converge. This is because the limit as n goes to infinity of the fraction 1 over n plus 1 over n is equal to 1. This comes from the fact that this quantity is a fraction of polynomials with the same degree and the same leading coefficients. According to the ratio test, the series converges if the absolute value of 9x plus 7 is strictly less than 1. This is equivalent to the inequality -1 less than 9x plus 7, and 9x plus 7 less than 1. We distribute -7 to all sides of the inequality, and obtain a new equivalent inequality, -1 plus -7 less than 9 times x, and 9 times x less than 1 plus -7. This inequality can be further simplified to the inequality, -8 over 9 less than x, and x less than -2 over 3. Consequently, the radius of convergence is equal to 1 over 9. The series converges for x in the open interval with endpoints -8 over 9, and -2 over 3. Given that the ratio test is inconclusive when the absolute value of 9x plus 7 is equal to 1. This means that the series may converge or diverge at the endpoints of the interval of convergence. We will now study two cases, when x is equal to -8 over 9, and when x is equal to -2 over 3. When x is equal to -8 over 9, the series becomes an alternating series with terms -1 to the power n times 1 over n. We will now investigate if this new series converges or diverges. Using the alternating series test, the series converges because the limit as n goes to infinity of 1 over n is equal to 0, and the sequence 1 over n is obviously decreasing. When x is equal to -2 over 3, the series becomes a series with terms 1 over n. The series diverges because it can be compared to a p-series with p equal to 1, which is less or equal to 1. In sum, the radius of convergence is equal to 1 over 9. The series converges for x in the half-open interval with endpoints -8 over 9, and -2 over 3.